All right, just get starting recording. All right, so today it's music video day. You'll find out what that means in a second. In a couple minutes. But we're going to be talking about flow control today, and that's essentially what we're going to be talking about is conditionals, if-then statements, and loops. And my dog got her toy behind like the set of dumbbells, and like she just moved a 25-pound dumbbell. Like, how did you do that? You are not that large. But anyway, we're going to start off so the idea is that using some of the techniques we're going to talk about today, we're going to give you a bunch of different tools that you can configure and use in a bunch of different ways to kind of get to some kind of solutions in your code. I think it's important to realize in programming, there's never one way to do things. Like everything can be accomplished a number of different ways. And I think that I think that there is never like the right answer in programming. I think that we always say that there are better solutions and worse solutions. Someone said that, and I generally agree. But I think there are definitely like some wrong solutions. There are some solutions that are straight up wrong. There's nothing that's ever right. There's some that are better and some worse, but there's definitely some that are wrong. And so we need to kind of like give our application a way to do things multiple ways, or to provide a different kind of path that they can take. And the analogy I use is like, let's say you download a game on your phone because we're not going anywhere. We need some way to fill our time. And if you just started the game up and it said you win, would that be a very satisfying game for you? Like, no, like it doesn't really do anything, right? And when we think about games that we play on our phone, or like games in general or anything, there's like some kind of decision path. If this thing happens, then we do that. And so we're going to talk about the building blocks then. The first thing we're going to talk about are conditions. Katie, what's a Boolean?
So a Boolean just checks to see if something's either true or false.
Mm-hmm. It doesn't check. It is literally either a value that is true or false, something that is true or false, right? And so what you're talking about is a condition. And a condition is something that evaluates to Boolean. So if we open up a prize session, please let me know if this is not big enough. This was the same size as yesterday, so it should be good. If we do play again equals true, play again, is true, right? It evaluates to true. That is a Boolean value. Boolean value is either true or false. And what we can do with this is that we can use comparison operators to create a condition by comparing two values. The most important ones are the double equal. So if you do 1 double equals 2, this should evaluate to false, because 1 does not equal 2. 1 equals 1. So we see that 1 double equals 2 is false, and double equals 1 is true. It's very important not to get this mixed up with the single equals. The single equal is when we are assigning something to something. The double equals is that comparison operator. And then we can go through all the comparison operators that you learned when you were like this high in school. You have the greater than, you have the less than, the greater than, equal to. I always think of it in my head as alligator mouths, and the wide part of the mouth is pointing towards the bigger one. That's how I remember these things. I have ridiculous methods for returning these things in my head. I think the one that you may not be used to is the not equal to. And that is going to be, excuse me, the exclamation point equal sign. In Ruby in general, in computing in general, the exclamation point usually means not. So when we do 1 not equal to 2, this should return as true because 1 is not equal to 2, right? Let me see that's true. And so we can set variables, compare them. Mood equals hungry. And we can see, is mood equal to sleepy? And you'll see it's false, because I am not sleepy, I am hungry. Right? And you can make different kind of comparisons. Like you can see mood dot length. Is my mood, the length of my mood, greater than 5? Yes, it is, because hungry is 6 letters, and it is therefore greater than 5. Regina?
So I don't know if I'm saying this right. When you put mood equals, oh, never mind.
Double
There's one
equals.
equal sign. I was thinking that it was like reassigned, but never mind. I see where it's at now.
I signed it
Okay.
here, then I did the jump. See that?
Yeah.
Yeah. That's what I was
Got
talking
it.
about. Like it's very careful to remember. Single equals is assignment. Double equals is the comparison.
Yeah, I just missed that. So okay, thanks.
Sure. That's fine. We saw here that the bang equals not. The bang operator also can be used to kind of do the opposite of. For example, if we do something equals true, oops, and we put a bang something, it will give us the reverse that, false. Usually, excuse me, people use the word not interpose that with the bang. Like, so it's like bang something is not something. So what is something? Something's true, not true is false. It's very important to kind of like think about how we are structuring our English. Like, I think that I try to think in terms of positives, like is something positive? Thinking about things in the negative sense often like makes me like kind of turn things around. When we are constructing comparisons, like I would say it out in English, just say it out loud, and then when you hear the sounds, like, does that make sense? If it usually makes sense to you, like that's generally pretty good to go. There are also built-in Ruby methods that can be used in conditions. And although this is not a rule, a hard and fast rule, generally Rubyists like to end these methods with a question mark. For example, one.even question mark. The even question mark method is going to tell us if the object we call it on is even or not. Is one even? No, one is not even. So I can expect that this will turn me a false. 2.odd. This should give me false as well. Cool. Any questions so far about these comparison operators? No? Yep, Doug?
So just as a quick clarification, from a like a best practices, if I'm asking a question, but I'm not trying to get a even or a true or false statement, I wouldn't put a question mark. But if I'm trying to get a true or false statement, okay.
Generally, what we're doing with that question mark is signaling this method is going to return you a true or a false. It's kind of like this explicit signaling that we're trying to do. Cool. Other operators that we need to know about are the or and the and operators. And what they do is they kind of combine two conditions into a single condition. So if we have breed equals corgi, oops, that needs to be in quotes. And we have age equals 3, nope, 2. When we use an or operator, it will return true if the thing on both sides is true. So here, if we do breed equals corgi, oops, nope, corgi, age, we do this. We're saying we are trying to find out if the breed is a corgi or its age or the age is equal to 3. This will return us true because this side of the or operator is true. It doesn't care about this side. Like, as long as one of these is true, the whole thing will return true. And that's how the or operator works. And we also have the and operator, and it's going to look like this. Let's do 3. So is the breed corgi? Yes, it is. Is the age 3? It is not. So this should return as false. What the AND operator does is that it will only return true if both sides are true. So again, the OR operator will turn true if either side returns true. The AND operator returns true when both return true. Questions so far? I think that it's very, very important to note that these operators and these comparison operators do have their own order of precedence, kind of like PEMDAS with math. They do have their own, and you can look that up. Personally, I just use parentheses everywhere to make sure it's very explicit in my mind what I'm trying to accomplish. So like, I'll be very, very cognizant of like, if you have comparison operators are not working the exact way you want it to, look into the order of precedence. That can definitely give us some issues. Cool. Any questions about conditionals, comparison operators, or Booleans here so far? Cool. Pretty straightforward. Like this is some schools might have taught you the and the or in some logic classes, but the standard conditionals is something we should cover in math. But let's move on to conditional branching. And the idea is that conditional branching is when we have a choice that is made depending on whether or not a condition is true or false. Anyone remember those old Choose Your Adventure books where you get to a thing like you made choice A, you go to this page, you made choice B, you go to that page. This is very much the same kind of thing. And to illustrate that, I have a music video, which is amazing. All right. So they showed you like an example of how conditional branching worked in Python, but let's take a look at it in Ruby, right? So we're gonna use the example of students in the class and their GPA, right? And so we would do if GPA is greater than or equal to 3.8, what we're gonna do is we're just gonna pretend we have a method called invite to honor roll. The end. Oops. No. This is why autocomplete is the worst. Right. So what's going to happen is if the GPA, the local variable GPA, presumably has a number in it, and if it is greater than or equal to 3.8, it invites the honor roll. And the idea is that, well, if it doesn't, what happens if the GPA is lower than 3.8? Andrew J.
Nothing.
Yeah, nothing happens,
don't have
right?
else. Yeah.
Exactly. Right. We don't have like any kind of additional conditions, so that's fine. And so we can also have the two branches. Let's say if just got paid equals true, we're going to go have a fancy dinner. Else, cook at home. And this is a two branch conditional, where if we just got paid, we're going to go out and spend that cash because it's 2020. We're not making good decisions. We're just doing what we can. And if we didn't just get paid, we're just gonna cook at home, be responsible. At the beginning of the pandemic, I was like, you know what? I need to support local restaurants, and then I gained like 5 pounds. I'm like, no, I need to support restaurants, but I need to support them a little less. So all of our conditional branches begin with this if, and the code following the if, that indented part, that's called, we call that the block, we will run if the condition is true. And this is what we have here is else condition that kind of catches if something isn't true, but we can also add additional conditions. So we can put here an else if. So we do if GPA is greater than 3.8, it's fine. Else if GPA is greater than 4.2, become valedictorian think I spelled that right. Else. Good job. Sure. So in this case, we are trying to structure things so that different things happen. But what's the problem? What does anyone see a problem with this conditional? Jordan?
Yeah, so as it is right now, if your GPA was 4.3,
Yeah.
you'd get invited to the honor roll, but not become the valedictorian.
Exactly, right. And this is something that you got to be real careful when you're making conditionals, especially multiple conditionals like this. You have to figure out, like, am I ordering them correctly? For example, like Jordan said, if this person had a 4.5 GPA, they would get invited to honor roll, but they'll not be valedictorian. So you want to, like, how I generally think about this in my head is that I want to structure it so the least likely case is checked first. So if I want to restructure this, I would do if GPA is greater than 4.2, valedictorian, else if GPA is greater than or equal to was 3.8, honor roll, else if GPA is greater than or equal to, I don't know, 2, diploma, else, oh no. And right now we've kind of structured this in a way where we have not created any kind of like situations where a condition is going to hit something that it's not supposed to. I do want to note that once we hit, like for a case where GPA is greater than 4.2, this block here, this line of code, and only this line of code will run. None of the other indented bits of code will run at all. Kyle?
In general, is it, in terms of like the exclusivity or inclusivity of some of these statements, like it seems like the majority of students would end up just getting the diploma. And so
Sure.
does it, do we also want to think about how many lines of code are going to run before the majority of conditions that are met hit that statement?
That would be something I'd worry about later. I think it's for your first pass, it's like, hey, I just want to make sure this is as clear as possible.
Okay.
The idea is that in Ruby, we want to be concise. Yes, conciseness is important, but clarity is even more important. We want to be able, like right now, if you just look at this, you're like, yeah, GPA, high GPA, valedictorian, good GPA, honor roll, okay GPA, diploma, bad GPA, oh no, right? It's very clear, like the structure of this, right? We're like Ruby is very expressive. We want to communicate as much as possible. So I would like err on the side of like, hey, I'm trying to communicate as much as I can beforehand. That's a good question. Cool. Also, like in general, not always, you will want an else case to kind of catch anything you've not thought about. There's always going to be something I didn't think about. I think that this is also something that you should do in your testing is like when we have a method you want to test for like edge cases, like unexpected results. Cool. Kyle, is that hand still up or is it a new? Cool. So to kind of sum up conditionals, conditional branches have only one. There's only one if. If you have additional branches like we have here, you use the else if. No E in the else if. A conditional branch will have 1 or 0 elses, and the elses generally you want that to be the last thing. Also note that each branch, only one will evaluate in a conditional, and that this will get processed in order because as we said like before when we had the honor roll above the valedictorian, that was kind of like not a great path. Like these things will like check in order, and once we hit a branch that returns to true, that will run and it will not do anything else. Like none of the other branches will run. Questions about conditionals? Jake?
So just piggybacking off of the last lesson we had, do we need to be thinking about flow control, or I'm sorry, scope, and what things we can hit with our different if, else, ifs, whatever? Because I'm imagining we're going to be doing these like
yeah.
inside.
As long as they have access to the local variable or access to the variable, you're fine.
Okay.
Right? Like the idea is that if this conditional doesn't know anything about GPA, like, well, that's not going to work. So GPA has to be defined inside that scope that you're working at or passed in.
What I was thinking more is going the other way with it. Like if this happens, then it's going to like change an array higher up in the scope, and it just has to like be in that line, right?
Yeah. Well, it's still, again, it still has to have access to it.
Right. Okay.
Right. And generally you don't want to do too much inside the branches. You'll be wanting to call like other methods that'll do the thing for you. Right. Because if we just have each branch of the code do the whole thing, then our code starts getting like super, super long, super, super quickly.
So good practice would be for each to do like one thing and then like use that return variable and put it somewhere else to like do the next thing.
Mm-hmm. That sounds pretty reasonable. Cool. Awesome. Let's take a 5-minute break and let's be back at 11:40 where we'll talk about loops. I mean, is that not the dream? To make a living writing rap songs about programming and burritos? Like, I cannot think of like a better life than that. Cool. So we're talking about loops, big surprise. And in the video, we saw an example of what's called a for next loop. A for next loop is kind of like how we used to do looping. And you may have to do that in various languages. In Ruby, we never use for next looping because for next loops, the problem with them is that you often have like a common error in computer science is called an off by one error. And it's very easy to kind of like miscalculate how many times you want to do a loop. But we want to show you some ways, some very different techniques that we can use in Ruby. And so a loop is a set of instructions that we do over and over again until some condition is met, right? And so the first way we do this is with the times operator. And so without knowing anything about loops, if I did this, oops. If I ran this, what do you think we would see on the screen? Having never seen this before. Jacob, what do you think? When I hit enter, what am I going to see on the screen?
5 hellos on the terminal.
Yep, 5, right? And that, like, again, this is like kind of why like I really like Ruby, because it's like ostensibly you've never seen this times method before, but it's like, well, I think I can figure this out. And we can add what's called a block variable to this, where we can, there we go, where it will print out whatever number we're on. Do that again. You see 0, 1, 2, 3, 4. And that's the basic loop is like, hey, we want to run something 5 times. Let's do that. And so this is kind of like the big power of computing, is that what computers do for us is that they give us a way in which we can do very small repetitive tasks over and over again without complaint pretty easily. Brisa?
Is there a way you can combine that to say like 1 hello, 2 hello, 3 hello, so that
we can combine that? And the technique I would use to do that would be string interpolation. So I do hello that. When we do that, oops. That will take whatever this is and print that out, build a string with it. And see hello 0, 1, 2, 3, 4, et cetera, et cetera. Cool. So this is a technique when we know exactly how many times you want to run something. But we have other loops that will run indefinitely until a different condition is met. And so what we do, the first one we're going to look at is the while loop. And how the while loop works is that we have while condition, and we have code in here. And this will, the while loop executes so long as this condition evaluates true. An example of that is while parking spot dot full, keep driving. So it's essentially asking, hey, is the parking spot full? Yes. We'll keep driving, looking for parking in the mall parking lot, looking for a parking spot. Then you keep, you've driven a little bit. Is the parking spot full? Then we execute, keep driving again, and it keeps going until you find until parking spot full gives us a false, and then we execute that, and presumably after the loop we would have a park car method here, and this will only run after we've found a spot. Cool. And so that is the while loop, which again, the main thing to remember about the while loop is that it executes so long as the condition evaluates to true. So the corollary to that is the until loop. I'm having struggles today with hand-eye coordination. And what the code executes, whatever is in the block, will execute until this condition returns false. Essentially, it's the opposite of the while loop. So while we have while parking spot is full, keep driving, with the until loop, we're going to do until parking spot dot empty. And then park car. And both of these do essentially the same thing. Again, the while loop executes so long as the condition evaluates to true. The until loop executes until the condition is false. I think personally, I don't like using the until loop because I struggle thinking in negatives, because then I get into a situation where I'm like, I have that double negative and I'm like, what? And I get really confused. So I generally try to stick thing to the while loops. That is just a personal choice. That works better in my mind. You should do what works better for you. The one corollary is like, I probably won't use a while loop if I'm trying to do a not. So like I want to find a condition where it's like parking spot is full. I would not do while not empty, right? Because then you have that double negative situation. And you're like, wait, not empty? Am I the only one that struggles with double negatives, or am I okay? Cool. There's enough head shaking in the crowd that like I feel validated in my choice. I realize like sometimes my preferences are like just weird, and sometimes I need to know like if it's just me being weird or if that's just a humanity thing. But yeah, questions about the while and until loops? Great. Finally, the last loop I want to talk about today, because I want to make sure we have like plenty of time for questions, is just the loop. And what this does is that this will run forever. It will just run forever. And what we will do is that you can make it stop programmatically using the break keyword. I'll show you how to do that in a bit. The one thing I do want to mention is that as you are working with loops, you may accidentally create for yourself an infinite loop where something just runs because they'll never hit condition because you just made a mistake. How you get out of that on your terminal is hitting Control-C. Not Command-C, Control-C. Control-C will force a halt of the execution of your code. And so I want to show you an example of how we could use this loop thing here. So we could do count equals 0. Under the loop do, we're going to do count plus equals 1 if count equals 10. Break. So what this is going to do is that we're going to set a count, a local variable equal to 0, and then we're going to start a loop. Every single time we're going to go through this loop, it's going to add 1 to the count. As soon as it's done it 10 times, it's going to stop. Break will exit the loop. And so this is a way to do something until something happens. This is kind of a way to force the halt of your loop. I think that it is easier to get into a situation where you have an infinite loop using the loop do as opposed to the until or the while loops, because you are not inherently setting a kind of like a condition to break it. I think in general, it is a better idea to stick to the while or the until loops, because like at this point, you're never going to be writing any kind of software that will run indefinitely. Cool. And that's all I have for loops today and control flow. Questions about anything we've covered this morning? Kyle.
I'm curious if you could just give an example of when you would do an infinite loop and then use a break, or why you would use that that control flow over until or
things that would just run forever.
Okay.
Like a web server, right? Like things that you don't expect to ever kind of stop. Like the applications you're going to be making in module 1 will hopefully stop at some point, or by design stop at some point. So this is not like, I would not use that as my first reach of tool. Like you certainly can. Break would certainly work. And you may find it easier to do that in certain circumstances, but I just think that like getting used to setting up a conditional is going to save you a little bit of headache in the meantime. Genevieve?
So I might be jumping ahead here, and I was just curious, but will we also be covering, kind of when you use if, else versus case when at a later time?
Yeah. We can cover right now. I would steer you away from using case.
Okay.
Not many people use the case statements. I've been looking for a while to figure out like why people don't. And the reason why, the only good reason I found is that implementation of how case statement works varies from programming language to programming language, and getting used to how it works one way is a bad idea when you transition to another one. It's a pretty weak reason why, to be honest with you, but it's just something that we just don't see very often. People just don't use it often.
Okay.
Yeah, I wish I had a better answer than people just don't use it.
Hey, it works. Thank you.
Yeah, no problem. Alexa? I cannot hear you. Still cannot hear you. You're unmuted, but I can't hear you. You're muted. Oh, I heard something.
Can you hear me now?
Yes.
Okay.
You're back on mute. Nope.
Can you hear me now?
Yes.
Okay, sorry. Can you
It's all
just
right.
repeat the while and until and how they?
Yeah. So the while loop will execute so long as the condition in the while loop evaluates the true. Until is the opposite. Until loop executes so long as the condition evaluates the false. I will use whichever loop forces me to not use a not in the condition. Oh my gosh, this is, if I have to use a bang in the condition, I will avoid doing so, and I'll use whatever loop requires me not to use the bang. I will also use that tool of saying what the condition is out loud to see if it makes sense out loud. That is what governs the choice of which condition you want to use. Cool.
Thank you.
Yep. Doug?
Yeah, so question on if statements. When I was going through some of the pre-homework for Mod 1, one of the things that they had stated was try to do this without if statements. I was wondering if that's a convention thing or if that was just to make you practice what they wanted you to practice.
Oh, that was like, that's something, sometimes you throw stuff in there to make you break your brain a little bit. And to like get you to explore things. No. You should use, you should try to use if statements. That question was put in there to make you think like, well, what if I had no access to if statements? How would I do this? Right. It's more of a brain
that's kind of what I thought.
A functional thing. Yeah.
That's what I thought, but I wanted to find out.
Yep. Chris?
Yeah, so I don't know if this is important, but I noticed on your while statement, you put condition.full and it was like calling to a method. Should we get used to writing our conditionals or the conditions in a separate method, or just writing out?
That is a very fantastic question. Pulling your conditions out into a method is a technique called using predicate methods. I'm a fan of this when you have complex conditionals that are kind of like annoying to get your head around. Like if it's something like if something equals 2, I'd probably leave it. That's not really worth doing. But if we've got like a couple of nested ors and ands in there, I'd pull it out to a predicate method.
Thank you.
Cool. Anything else? Doug, is that a new question or an old question? Cool. Awesome. That's it for the day. This afternoon, let me check the calendar real quick, is going to be your first independent challenge. This does not require a Zoom call. There will be an attendance thread, so you're expected to put the attendance thread in. At 1 o'clock, I'll be posting instructions for the independent challenge in your Slack channel. Important, like as you're doing from 1 to 2:30, commit often, but do not push till the end. And the idea is that we want your pull request in at 2:30, or at least as close to 2:30 as you get. And what we'll do is that throughout the rest of this afternoon and this evening, Bob and Megan and I will be going through giving you feedback and scoring them. We're going to try to get to all of them tonight. After the independent challenge, you have half an hour. We'd like you to spend that hour. We're going to give you the hour to reach out to your mentor, start building that relationship now. That is going to probably be one of the biggest keys to success. Reach out to your mentor, reconnect with them, write them a long email, et cetera, et cetera. At 3 to 4, we have given you time to work on the PD stuff that you have from this past Monday. That is going to be your designated PD work time. Bob, Megan, and I will be unavailable at between 3 and 4 because we have our back-end team meeting then. One last thing I want to add is that during the independent challenge, if you have clarifying questions, DM all of us. Like, we have no problems answering clarifying questions during the thing. But that is it. Let us know if you need anything else. Other than that, have a good lunch. We'll see you. Well, we won't see you, but we'll talk to you at 1.
Really
Goodbye.
quick,
Go ahead.
Oh, where did you say we check in? I'm sorry.
Check in for...
just to like say that we were here at 1.
Yeah, there's going to be a Slack thread in your channel.
Okay, cool. Thank you.
No problem.